Imagine a world without weather forecasts, GPS, or global communications. Seems impossible, right? All these services wouldn't exist without satellites. These are not just fancy pieces of technology orbiting Earth, they are the silent heroes that make modern life possible. From pinpointing your location on a hiking trail, to transmitting your favorite TV show, to even predicting tomorrow's weather, satellites play a crucial role. But what exactly are satellites? They are objects in space that orbit around larger bodies, like the Earth. Some are natural, like the Moon, and some are man-made. The ones we're focusing on today are these man-made satellites. They are our eyes and ears in the sky, helping us to connect, navigate, and forecast. So, ready to discover the secrets of these silent heroes orbiting our Earth? Strap in, it's going to be an exciting ride. First things first, let's get to know our heroes. Satellites come in all shapes and sizes, each with its unique purpose. Now, what is a satellite? In the simplest terms, a satellite is a celestial body or a machine that orbits around a planet or a star. They are not all the same. They vary in size from small CubeSats, not much bigger than a loaf of bread, to massive structures like the famous Hubble Space Telescope, which is about the size of a school bus. These high-tech marvels serve a multitude of purposes, from studying the far reaches of the universe to helping us find our way to the nearest coffee shop. Speaking of purposes, let's delve into the different types of satellites. Weather satellites, for instance, play a crucial role in forecasting weather and tracking hurricanes. They constantly monitor the Earth's atmosphere, providing essential data for meteorologists to make predictions and issue warnings. Then we have communication satellites, the unsung heroes that make our global communication possible. From broadcasting television signals to providing internet connectivity in remote areas, these satellites are the invisible backbone of our connected world. Moving on, we have navigation satellites like those in the Global Positioning System, or GPS. These satellites help us find our way around the world, be it driving across the country or hiking in the wilderness. They provide precise timing and location data to GPS receivers, which is then used to calculate our exact position on Earth. Lastly, there are scientific satellites like the Hubble Space Telescope, which help scientists explore the mysteries of the universe. They provide invaluable data about distant stars, galaxies, and other celestial phenomena, contributing to our understanding of the cosmos. Now that you know the types, ever wondered how they stay up there without falling back to Earth? Gravity keeps us grounded, but it also keeps satellites in motion around the Earth. This invisible force, discovered by Sir Isaac Newton, is the reason why an apple falls from a tree, why we don't float off into space, and why satellites keep circling our planet. So how does gravity work in space? Picture a giant trampoline with a bowling ball in the middle, that's Earth. Now picture a marble rolling around the edge, that's a satellite. The bowling ball creates a dent or a well that the marble rolls around. This is a simplified analogy of how gravity keeps satellites in orbit. Now, onto the types of orbits. First up, we have the geostationary orbit. Satellites in this orbit stay in the same position relative to the Earth's surface. This is ideal for weather satellites or communication satellites, as they can consistently monitor or communicate with a specific area. Next, we have polar orbits. These satellites zip around the Earth from pole to pole, covering the entire planet as it rotates underneath. This is perfect for spy satellites or Earth-observing satellites like those used by NASA for climate research. Finally, we have low Earth orbits, where most satellites reside. This includes the International Space Station, which orbits the Earth once every 90 minutes at a height of around 250 miles. That's about the distance from New York to Washington, D.C. These satellites are closer to Earth, which makes them ideal for tasks that require a more detailed view of the Earth's surface. Think Google Earth or satellite TV. The type of orbit a satellite uses depends on its mission. Whether it's to observe weather patterns, provide communication services, or spy on other countries, each satellite has a specific orbit that allows it to do its job effectively. So they keep orbiting, but how do they communicate with us? Satellites are like interstellar postmen delivering data to and from Earth. Imagine you're sending a letter to a friend across town. You jot down your message, pop it in an envelope, and hand it over to your friendly neighborhood mail carrier. Now imagine that friend lives not across town, but across the universe. That's essentially the job of a satellite. Communication satellites are the mail carriers of space. They use radio waves to send and receive data, just like your local postman uses a van to transport your mail. These radio waves, which are part of the electromagnetic spectrum, are picked up by antennas and receivers on Earth, effectively delivering the satellite's letter. The process is a little more complex than our mail analogy, of course. The data sent by satellites can include anything from television broadcasts to weather images, and it's all encoded into these radio waves before it's sent off into the universe. But like any good mail carrier, satellites need fuel to keep going. In this case, that fuel comes from the sun. Most satellites are equipped with solar panels that soak up sunlight and convert it into electricity. This powers all the satellite systems, from its communication equipment to its onboard computers. But what about when the sun isn't shining? Well, that's where batteries come in. The electricity generated by the solar panels can be stored in batteries for use during periods of darkness, like when the satellite is on the dark side of the Earth or during eclipses. Let's take the example of communication satellites again. These workhorses of the space industry rely on this solar power battery combination to keep their equipment running and their data flowing. It's a delicate balance of power management, but it's essential for keeping our modern world connected. So we've got our interstellar postmen, equipped with their solar-powered vans delivering letters to and from the far reaches of space. But how do they get up there in the first place? The journey of a satellite from launch to retirement is nothing short of an epic space adventure. Let's embark on this journey together. The launch process is the first thrilling step. A satellite like SpaceX's Falcon 9 is placed into a rocket, which is then fired into space. The rocket ascends through the Earth's atmosphere, traveling at speeds of up to 25,000 miles per hour. Once the rocket reaches a certain altitude, the satellite is deployed and the rocket falls back to Earth, its mission accomplished. Once in orbit, the satellite begins its operational phase. Depending on its type and purpose, it may capture images of the Earth, transmit television signals, or aid in scientific research. Satellites are equipped with advanced technology to carry out their tasks. They receive commands from ground stations and communicate back with data and images. This communication process is a delicate dance of signals traveling at the speed of light. But what happens when a satellite reaches the end of its operational life? Well, it doesn't simply disappear. Satellites are either moved to a graveyard orbit far away from operational orbits, or they're de-orbited to burn up in the Earth's atmosphere. This ensures they don't pose a risk to other satellites or to the International Space Station. The end of a satellite's life isn't the end of its story, though. Every retired satellite contributes to our understanding of space technology. The data they've gathered, the challenges they've encountered, and their operational histories all feed into the design and operation of future satellites. The world of satellites is ever evolving, with new challenges and developments on the horizon. The future of satellites is as vast as the universe itself. As we continue to explore the cosmos, we also face a few challenges. One such challenge is the increasing congestion of satellites in space, also known as space junk. This poses a significant threat to both existing satellites and future missions. But fear not, space enthusiasts, as innovative solutions are already in the works. Take, for instance, the Starlink project by SpaceX, a satellite constellation providing global broadband coverage. It's a quantum leap in satellite technology, but it also adds to the space traffic. So how do we address this? Well, future developments include space cleanup missions designed to safely deorbit defunct satellites and reduce space debris. The journey of discovery doesn't end here. Dive deeper, learn more about satellites, and join the conversation. The universe is waiting.